Hello and welcome, Omid here, and what I'm going to do is to give you an overview of what we are going to have, and also I'm just going to speak about two of these topics right now in short. After that, in the later videos, we're going to talk about binary notations and how we can just convert them into decimal, how we can convert decimal into binary, and also hexadecimal as well. We're going to talk about subnet mask and the importance of subnet mask. We are going to talk about subnetting. Some of the concepts that I'm going to speak about right now might not be very familiar for you, and of course this is going to be just an overview, just a touch to the surface of what we are going to talk about in the future. But right now, just listen to this and try not to memorize this, just get familiar with what I am talking about. First of all, we have two different routing protocol on the internet, and also most of the networks use these protocols. And these two are going to be IPv4, and this one is pretty old, and the other one is IPv6. IPv4 is going to be the most dominant, as a matter of fact, the more dominant protocol. The reason for that is you use IPv4 inside your enterprise for sure, and also on the internet IPv4 is very common. But the number of IP addresses that we have for IPv4, of course, is not so much. It's actually something like 4 billion, and from this 4 billion, a lot of them have been reserved for specific purposes. So as a matter of fact, what you are going to get is something around 3 billion. And 3 billion is not going to be sufficient for the number of devices that we have on the everywhere. So we have handheld devices, tablets, PCs, servers, virtual machines, and also appliances, and nowadays cars, and a lot of different things that need IP connection to the internet. So IPv4 is not for sure enough for all these devices. So what we are going to do, as a matter of fact, just to survive on IPv4 is we have to go with different technologies. Later you are going to get familiar with some of them, so IPv4 can kind of survive these days. But as a matter of fact, eventually we have to go to IPv6. IPv6 is not so new. It is more than 20 years old right now, but it hasn't been widespread because we have just tried to use IPv4 as much as we can. Anyway, we have to know about this, and whatever we know about this applies to IPv6 as well. IPv4 is a 32-bit IP address. IPv6 is something like 128-bit, as a matter of fact. But this 32-bit is going to be important for us. So what we do is we just divide this into different parts. I say I cannot really go with a 32-bit binary value. That's too long. What I'm going to do is to divide this into 4 different pieces. Each one is going to have 8 bits. I call this octet. So we have 4 octets in an IPv4 address. Each one of these octets, now that they have 8 bits, they can have a value from 0 to 255. Same thing goes to here, 0 to 255, 0 to 255, and eventually 0 to 255. So these are the values that we can add for different pieces. So an example for that, 192.168.1.1, for example. 192 is going to be this one, 168 is going to be this one, 1 is going to be this one, and 1 is going to be this one. So you can see that we have 4 different octets. Each one of them can have a specific value. But like I said, we are going to talk about this in more detail later. So we have 2 types of IP addresses. Well, one of them is going to be public, which means that you can reach to that through the internet. One of them is private, which means that you cannot reach to that through the internet. This is used for internal network, for your enterprises, for your home office, small office, for your, let's say, building, for different places that you have. You use private IP addresses. As a matter of fact, private IP addresses, like I said, are not reachable through the internet. You can reach to your network using something that we call it VPN, but that is kind of tunneling through the public network into your private network. We can talk about private tunneling later, but right now we just know that private IP addresses are not reachable on the internet and are not used on the internet. We call them, they are not routable. Because private IP addresses have different ranges. As a matter of fact, three different ranges. I'm going to speak about classes later, but you can say for class A, we have 10.0.0.0 up to 10.255.255.255. For class B, we have 172.16.0.0 up to 172.31.255.255. And for class C, as a matter of fact, we have 192.168.0.0 up to 192.168.255.255. So you have to memorize these things. That is something that we call it RFC 1918. RFC stands for request for comment, and that is kind of proposals that we have for different technologies about protocols or about how something should run inside the network. As a matter of fact, this one is one of the most famous ones. You can just take a look at the RFC on the internet, but that's a document actually that describes the usage of these IP addresses. But you should memorize this. This is very important for you to memorize this one. And finally, we have something that we call it multicast IP addresses. Multicast means that I am sending one packet, but multiple recipients are going to receive it. Let me just give you a very short hint about this. Say there is a streaming server in here that sends some video, let's say, or a podcast or something like that. Then there are 4 devices in here that they want to receive this podcast or video. So normally if I go with an IP connection, this is going to send one packet to this, one packet to this, one packet to this, and one packet to this, which means that it should send 4 different copies of the data towards the destination. When you go with multicast, as a matter of fact, this is not going to be like that. You have something which is called a router, maybe in the middle. You just register to this and you send one packet to this. The router is going to see how it can reach to these destinations. If these destinations want to receive the feed, the stream, or whatever, the podcast, for example, then this router is going to replicate it for them. Otherwise, the server sends only one copy. So that is called multicast. One sender, multiple recipients. So that is what we call it, a multicast. And the range of IP address for that, again, you should memorize this. That's going to be 224.0.0.0 up to 239.255.255.255. So like I said, one-to-many communication is going to be the rule of multicast. And we can see that in streaming, you see that in, let's say, IP cameras, you see that in let's say a video conferencing or something like that. These are different usages of multicast. Okay, I'm going to speak about binary notations and stuff about binary in the next video. I hope this has been informative for you, and thank you for watching.